Flack math! Give me some math and I'll give you some flack. Flack math!
So this is lesson 32. And we are going to solve word problems. With equations or with algebra. So you get to turn off all of your apps except your translator app, and we're going to try to form, double click. Well, you used to double click, right? Now it's just weird kinds of swiping. Okay, so let's see if we can translate this into an algebraic equation. Get it to where we like it. We don't like English. We like math. The sum of twice a number and 13 is 75. Find the number. Okay. I like these problems because that's confusing. But let's put it in math, because I'll do English in English, but I want to do math in math. Okay? So let's translate it into math so we can do the math. What's sum mean? Addition, right? So we know we're going to add a couple things. So whenever you see the word sum, usually you'll see the word of after that. And normally of in math means multiplication, but not here. The sum of, and then you're going to get at least two things. And in this book, in this Saxon Algebra 1 book, you will only get two things. So if I say the sum of, you're going to look for two things to add. That's it. So after the word of, you're going to get your first thing you're going to add, which is twice a number. So see this word of? That's where I start to see what I'm going to do. And then we have this connector word, and that's where basically where the addition sign goes. But and doesn't always mean addition. If I said the product of twice a number and 13, well, that means product means multiplication, right? So this is just a separator word that separates the two things that you're going to add. Not because it says and, but because it says sum, okay? You understand the difference there? So, how do you say twice a number? Yeah, 2n. So that goes on the left. Doesn't have to go on the left, I guess, but let's read it left to right. And then how do you say 13? Okay, so see how the sum of, and after the word of, you're going to see your first thing you're going to add. Then you're going to see the word and then after the word and, you're going to see the second thing you're going to add. So that's 2n plus 13. So far, so good? I know this seems like, well, duh. Why are you spending so much time explaining this? Well, it gets a little trickier, and it'll get trickier in this lesson. So when you're dealing with the sum, most of the time, you're just adding things and you're done with it. But if I were to say twice the sum, then you're multiplying the whole sum, this whole thing, times 2. How do you multiply a group of things by 2? What do you do? Nathan? Yeah, you do use parentheses. You multiply the whole thing by 2. That's not in this problem, but we'll get to that in a second. So the sum of twice a number and 13, how do you say is?
Equals.
All right, so this is equals. And then how do you say 75? 75, that's easy. So now we have an equation, a two-step equation. So now we go to our steps of equations. Everything's simplified. There's not variables on both sides, so we're just going to steps 3 and 4. This is typically what most of your equations will look like, steps 3 and 4. So get rid of the constant on the variable side. So get rid of 13. So 2n equals 62. Get rid of 2. n equals 31. Now, the best thing to do at this point is to see if it makes sense in the English statement. So sum of twice a number. Okay, what's twice 31? 62, and 13 is 75. Well, yeah, that works. Okay? All right, let's Saxonate it a little bit. Here's example 2. Find a number. So in this case, I kind of put the command on the first part of the problem instead of the last part of the problem. Find a number such that. So you'll see that sometimes, such that, and then this is where you need to translate. Find a number such that, so such that has no mathematical value. This is just saying find a number, and here's the clues that I'm going to give you right after the phrase such that. If 5 times a number, oops, sorry, that's example 3. Sorry if you wrote that down. Such that 13 less than twice the number is 137. Okay, this is a great problem. It's going to test a particular skill that I'm hoping that you guys remember. So how do you say 13 less than twice the number? Right? Good. So this less than, this is where you reverse. Okay, so you reverse what's in front of that less than and what's after less than. So you're reversing 13 and twice the number. Okay, so if you get confused, you can just use normal numbers. How do you say 2 less than 10? What's 2 less than 10? Well, that's 10 minus 2. Okay, what's a quarter till 4? Well, that's 4 o'clock minus a quarter of an hour. So, right? Or some people used to say, it's 10 of 5. 10 of 5. Don't talk like that. That's just confusing. Okay? 10 of 5. Or quarter to 4, or quarter of. It's quarter of 5. No, that doesn't make sense. 13 less than twice the number. So 2n goes here, minus 13 goes there. That's good. And then how do you say is 137? Equals 137. Perfect. Okay, so let's get rid of these guards. What do you want to get rid of first? Yeah, add 13 to both sides. 2n equals 150. Divide by 2. N equals what? 75. Good. All right, let's just make sure it makes sense. 13 less than twice the number is 137. Twice that number is 150. Minus 13 is 137. That makes sense. Okay? How's it feel? Okay? All right, I'm going to erase the board. I'm going to do at least 2 more examples, but we can do 3 if you guys feel like you need it. Okay? So let's try one by yourself. We'll compare a little bit. Make sure you're getting it right. Yep, now that we got the music. So, just in time, because I can have music to do this next example. All right, so example 3, find a number such that. Okay, so basically, whenever you see that, find a number such that, that's just like the intro to the problem. Once upon a time, in a land far away, there lived, okay, let's get to the point. All right, so this is find a number such that, let's just get to the point. So, whatever. I don't need the fluff, just tell me the stuff. Find a number such that if 5 times the number is decreased by, okay, you can use fancy words, I can handle it, by 14, the result, okay, I get that, is twice the opposite of the number. Okay, a little weird, but I got it. So one step at a time, we can do this. This looks confusing. If 5 times the number is decreased by 14, the result is twice the opposite of the number. If you left that in English, that would be a pain in the butt. All right, let's start thinking of numbers that might work. That's a pain in the butt. So let's translate it. How do you say 5 times a number? 5n. That's not bad, right? So 5n goes right there. Is decreased by. How do you say is decreased by? Subtraction. So is decreased by 14 is just minus 14. You don't have to switch the order. If I said 5 times a number less than 14, then you switch the order. But really the only phrase you have to watch out for is less than. Okay? If it's just is decreased by, that's just a straight subtraction problem. All right? Can you remember that? All right. How do you say the result is? Equals. It's just fancy talk, right? For equals. Is that what you do when you do fancy talk? Is that the SpongeBob fancy talk? Yeah.
Fancier you are.
Yeah. See, Audrey, you just understand. How do you say twice the opposite of the number? What? So twice, the number would be 2n, but what's the opposite of the number? Negative 2n, right? So, and really, if I translated it directly, it would say twice the opposite of the number. See why you need those parentheses there? What if you didn't have parentheses there and you just said 2 negative n? It's not 2 minus n, right? So it's 2 times negative n. Well, this just simplifies to negative 2n, right? A positive times a negative is a negative, whatever you're multiplying. Okay? That feel all right? Okay, and then this is the same. Do we need to simplify anything? We got rid of those parentheses. We distributed the 2 to the negative n. So we got negative 2n. Do we have to simplify anything else? No, there's no like terms. There's no more parentheses. There's no like terms. So what do we do next? Add 2n. Right? Because we have variables on both sides. So let's get rid of that 2n. Now, this is a case where you might have saved yourself a step if you got rid of the 5n instead of the negative 2n. But I think it's still less confusing to get rid of the smaller variable term. So you're left with 0 on the right side. But that's okay. You can still do step 3, which is get rid of the constant on the variable side. How do you get rid of minus 14? Add 14. So 7n equals 14. What's n? 2. All right, let's just make sure it works. 5 times the number, so 10, right? If the number is 2, 5 times the number is 10. Is decreased by 14. Okay, what's 10 decreased by 14? Negative 4. The result is twice the opposite of the number. What's the opposite of the number?
Negative 2.
Negative 2. So what's twice negative 2? Negative 4. You get negative 4 on both sides. That works. Okay? All right, I'm going to do one more. Let's see if you guys can do this on your own. And then if we need to do another one, we'll do one more, okay? So here's example 4. Here's what example 4 says. Find a number which is decreased by 18. Sorry, I said that wrong. Find a number which decreased by 18 is 5 times its opposite. Okay, does that make sense? Find a number which decreased by 18 is 5 times its opposite. So see if you can write an equation. Before you start solving it, see if you get the right equation. Compare with someone next to you. So if you were doing this on a test, if you wrote the right equation but then solved it incorrectly, I'd still give you half credit because you're translating it correctly. If you translated it into the wrong equation but solved that wrong equation correctly, I'd give you half credit. Because these problems demonstrate 2 skills: translating and then solving. You got it? Are you done? Do you want to go home?
After this class, this is my favorite class of the day.
10 of. It's 10 of 9.
So don't 9. Why of?
I don't know. People are weird. These are the same people that say, yes, it's Tuesday, it's Monday, it's Sunday.
Wait, people say that?
Yeah, people say it. I know. Monday.
Mr. Flack, can I go to the bathroom real quick?
Yeah. Since you're not doing math.
Whoa. I was daydreaming, man. I'm sorry.
Just do the math in the bathroom. That's weird. Okay, find a number which decreased by 18 is 5 times the opposite of the number. What'd you get for an equation? Who wants to tell me theirs? Lucia?
I got a minus 18.
Did you say A?
No, N.
Oh, I was like, A? That's a nice little twist.
N
I'm fine with A.
18 equals -5.
Right, so if I did it directly, so Jacia kind of in her head brought that negative out in front, and that's fine. If I did it directly, it'd be 5 times its opposite, right? Well, what's 5 times negative n? Negative 5n, okay? So if you want to do that right away, 5 times its opposite, okay, that's negative 5n then. That works. All right? Did everyone get that? More or less? Good. Elkin, did you get that? Don't answer. Okay, so what do we do now? Yes, Nathan.
Put the smaller variable on.
Yeah, get rid of the smaller variable. Let's just see what happens if I get rid of the larger variable. Okay? And the only reason I'm doing this is just to show you why, yes, it's one less step, but it's a little bit more confusing because of the negatives. So how do you get rid of that -6? Divide by -6. You just have to keep track of your positive and negative rules. And I know you guys know the rules. Negative divided by negative is a positive. But when you're taking a test, remember you're dumber when you take a test. And it's just one less thing to worry about. Did you guys get 3? Awesome. Good job. All right, so there is one more example. Let me just read it to you so you know what to be to look out for in your homework. This is what example 5 says. We get the same result if we multiply a number by 3 or if we multiply that number by 5 and then add 2. Okay? So we get the same result. So in this case, you're putting an equal sign right there first. We get the same result if we multiply a number by 3 or if we multiply the number by 5 and then add 2. That's the translation to example 5. Okay? So what is it? Negative 1? Okay.